one we're looking at now is not too far from the southern pole of the Milky Way galaxy. You know how the Milky Way is shaped like a frisbee? And so a frisbee has an axis, it has a North Pole and a South Pole. We're not too far from the South Pole. We're about maybe a couple tens of degrees from the South Galactic Pole. Each of these stars is in a somewhat different region of sky. They're not all in the same constellation. They were found, these stars were found by one of our colleagues, Yuting and my colleagues, a fellow astronomer, who used a telescope in Hawaii, actually used a telescope on Maui to find these to find these stars. Something called the Pan-STARRS survey, which used a set of telescopes located on Haleakala. And they managed to image something like 3/4 of the sky. Pretty much everything that's visible from Hawaii, they managed to cover. And so these stars are spread out all over the sky. And the ones that, but they got images, they took images, identified things that are pulsing in brightness, and we are trying to measure their spectrum. They're the first people trying to measure their spectrum. And by measuring the spectrum, we can tell how fast the star is moving. We may even be able to say something about its chemical composition, what elements its surface is made up of. But our primary goal is to measure its velocity, how fast it's moving towards or away from us. Because we think one of the things we're testing here, we know our Milky Way has grown through cannibalism of smaller galaxies. And there's a particularly big meal that our Milky Way is in the process of having. It's swallowing a big galaxy. That big galaxy has enough gravity of it. It's big relative to other small galaxies. It's much smaller than our Milky Way. It's about, LMC is what, 1/100th the mass of the Milky Way, something like that. But what it's doing, this galaxy that it's swallowing, the Large Magellanic Cloud, it is producing a gravitational wake. And we're trying to measure the effect of that gravitational wake by measuring the velocities of stars. It's pulling our sun towards it with a higher force than stars that are further away from it than the sun, and the reverse for stars that are closer to it than our sun. So it's creating this velocity gradient between us, we're located at the sun, and these other stars, and we're trying to measure that in this experiment. We got 4 nights on Keck and ESI to do part of this experiment in the spring, and we did that. Now we're doing the sort of fall sky portion of the experiment.